Hello, biomedical innovation students. So I'm going to talk through the results that we went through first period today so that you guys have those results here. You can go back to my explanation and hopefully it makes sense. I saw some confused looks today and I'm sure that did not stick 100%, but that's part of the process of learning something new. And so we're going to get this. You'll be fine. I also added some changes to the report template so that you can hopefully makes it a little bit easier. So if you've already started on it and you wanted to switch to this new template, it's basically the same file. You've already started. You can copy and paste your new stuff that you've done already into this new template if you think it will be helpful. So purpose of the experiment, background of the experiment, I've talked about that, like what's the overall goal. This is where you're going to talk about why it's important in research. So I've added in these headings too for the experiment summary. You're going to take your 612 organizer and basically turn that into like little narratives explaining what the goal and purpose was and desired outcome was for each of the 5 modules. Okay. Then we get into results. And so this is where I want to spend most of my time talking today and interpreting those results or looking at the results. So here you're going to put in pictures of, like you did have a gel in one of the earlier modules, you would insert a picture of that. Module 3, there really was not much in that one because basically, yeah, it grew on the kanamycin. That was it. All right. So go back through and look at the results from each of those. And think back to what we did in those parts of the experiment. If you need help, I can definitely help you with those. But once again, you're only being very objective here. You're only explaining things in terms of like what you observed and not explaining what it means. Okay. So in under module 5, I did put this gel in here. This is the gel image from the kit itself, from the module itself, that shows the final results. And then if you go back to the other slide, you can see the interpretation of it. And finally, I did put down here, and I called it an appendix. Appendix is like just an addition to the document at the end. At the end of this document, I put in these 3 images that show the results and what each lane means. So this was the image that I put in here for a correct 5' to 3' insert. It's single insert. 5' to 3' single insert. Right? So you can look at this to see what is in each lane, lanes 1 through 6. And this shows you that orientation, that interpretation. So I'm going to go back to Canvas under 612 results interpretation. There's a slideshow. And if I click on that, these are the results that I expected to get, right? These are the results that we should have gotten. And we did get really close on some of those. Some of you guys had some really good results. Maybe 1 or 2 lanes wasn't perfect, but that's okay. We did have some pretty good results overall. Reproducing this over so many days, every day that the DNA has to freeze and all that stuff causes error. It's better to do this in a shorter amount of time. So let me make myself smaller here or move myself out of the way so you can see this a little bit better. If you look at what we're looking at in the lanes, the standard marker helps us to determine size. So if I look, for instance, at this band in our, well, let's skip over to one of the lanes that's labeled down here. So you see 3,000 and 1282 are the 2 bands. So this would be the 3,000. So if you look at these bands here, you see the sizes of 6751, 3652, 2827, right? Well, this is supposed to be 3,000. So it should be between these 2 bands, the second and the third. And lo and behold, look at the bottom edge of it, falls right between the second and the third. So that's what those bands are for. Sorry, on this one. All right, 1282, okay? 1282, once again, goes over here between the 4th and the 5th, and that's between 1568 and 1118. So that's what the marker is used for. So what do these results mean? So and if you look here, the supercoiled plasmid vector standard basically is showing the DNA, that the DNA is 3,000 base pairs. That the linear DNA, when it's unraveled, is 3,000 base pairs. That's basically it. Okay, and the restriction digest control, the linear DNA is 4,282. So this is the plasmid, okay, and this is the DNA that's this is just the plasmid with no kanamycin gene inserted. And this is the plasmid with the kanamycin gene inserted, and it should be a 4282. And so if you look at that right here. It's between the 6751 and 3652 bands. So that falls in that range, okay? And so for this one. Now, when we go to these restriction enzymes, this is how we determine, did we get the thing inserted correctly, the right thing, the right size thing, and was it inserted in the correct orientation, and was there only one? So that's where we need to look at these other ones. So example 1, correct 5' to 3'. That just is the order where you have the promoter here and the rest of the gene here. This is the correct order, right? Basically, we want this XHO restriction site before the EcoR1 restriction site in that process. Before the PVU restriction site. Okay, and so if it's in the wrong order, then we will get a different set of results. So if you look here at example 1, we have our 5' to 3' orientation. Here's what happens if it's reverse. Okay, so if So if it's in reverse orientation, all right, look at the two slides. What do you see? If you look at the differences here, if you look at the EcoR1 cut and the PVU2 cut, no difference. Or, sorry, let me go back here. 5 to 3, 3 to 5. No difference between those two, right? Because we have inserted something, right? We've inserted our 5' to 3' thing. So we have a 1282, which is our gene. We have 3,000 base pairs as our plasmid, okay? So, and then total is 4282. Well, the same thing here. Okay, the only difference, if you look at the plasmid, look at how it's inserted. It's inserted backwards in example 2. Okay, being inserted backwards changes the orientation of that. So when you then look at the double digest of PVU2 and XHO1, all right, at the bottom, you can see, it keeps covering that up for some reason. Let's see if I can hide that. There, it was exit full screen and show it this way. Let's go here. So here you can see in the 5 to 3, you have this 3049 base pair segment with 1233. Okay, because it's going to cut, PVU2 is going to cut here. All right, let's see if I can zoom in a little bit more for you guys. All right, there we go. So the PVU2 is going to cut here. All right, and that leaves one cut, and the XHO1 is going to cut here. And so it's going to be taking this 3,000 plus the 49 that's right here, and that leaves 1233 for the rest of it. If it's inserted backwards, okay, now the PVU2 cut goes all the way through here in most of the gene of the XHO1. And so that's why it's 3977, much longer fragment than we have here. Okay, and so then we have this, then we would have in this situation. So you see the longer fragment is longer in a 3 to 5 orientation. So that's how you can tell that you have it backwards, is because of the fragments. How do you tell that on the gel? Because you have this small fragment here. Now, how do you tell that on the gel? Let's go back to present mode. And if you look at the gel for this situation, here's the 5 to 3. Look at lane 6. Okay, lane 6, we have our 3049 and 1233, and now I switch. Wow, look at that difference. All right, just look at lane 6. You see the difference. There are some other subtle differences. These don't matter so much. Okay, now this little band right here is showing that little tiny fragment. And so that difference tells us that it's inserted backwards, which is causing this PVU2 segment, or this cut, which including the plasmid and most of the gene, to be really long, and this gap to be really short, versus this orientation. Okay, and so that tells us it's backwards. The other thing is we want to make sure it's not double inserted, and so that's a little simpler to look at, because all you really need to look at is this second cut, the PVU2 cut, right? Because if you look at that one, it's 4282 in a normal orientation. Well, in the 3 to 5, it's also 4282, right? If you don't see a difference in these two, right? So if you look at lanes 3, lane 4 and 5, from this one to this one, there's no difference, okay? But if you look at that compared to the example 3 with the double digest, and then there is a difference. Now, it's much more subtle. It's much more subtle because the difference is not that much greater, and this is like logarithmic. But if you do the actual measurement, you look at where this one is on, this is the normal one, right? The 5 to 3. If you follow this over, all right, it's 4282. All right, and if you do some actual, calculations, you'll see this is a little bit closer to that one than this one is. It's really hard to interpret that. I'm sorry, this one is. So this one's just a little bit higher. And there's a gel interpretation I'll show you guys in class that kind of proves that. I'll put this picture onto a measuring app that shows that. But also, the other thing is you will see that the sixth lane looks much different too, right? Because since you have two insertions, all right, since you have two insertions, you're also going to have multiple cuts here. So you're also going to have this extra 1282 because PBU2 is going to cut here. PBU2 only cuts in the plasmid, right? So you still just have that one cut, but the XHO1 cuts twice. So you have this one segment that's really long, then you have one that's exactly the length of the gene from XHO1 to XHO1, and then this other short one. And so that's why you'd see 3 bands in that situation. So what do you do with that information? Well, what you do now is use that to kind of explain. So this kind of, for the results, you're not really going into all the explanation. For the results, you're just explaining what we see, like what does each lane mean, what happened in each lane, and definitely these charts up here are going to help you with that, right? You'll talk about the sizes of them. But down in the summary, in the analysis conclusion, that's where you're going to go into interpret the results. So one of the things is going to be talking about the gene orientation, okay, and how you know that if you get these results, how do you know that these results show that it's in the correct orientation, 5' to 3', that it's not reversed 3' to 5', or that it's not double digested. So make sure you have that information included in there. Make sure I put the right. I might have put the wrong one in there. Yeah, I did. So I'll change that picture out and put the correct one in there. So for the final report template. So because this is showing the double digest, so I'll delete that, put the correct one in there. So hopefully that helps you a little bit more with that. And please reach out to me though if you're having trouble with and ask me questions in class about it. This is not due until next Friday, so you still have quite a bit of time to do that. So next Friday, I don't even know what date that is. That would be February the 5th. All right, next Friday, February 5th is when this is going to be due. So, all right, hopefully that helps, and feel free to watch this again to help you interpret those results. Thanks. See ya.